everyone, let's get started. We are on improper integrals, type 1. There we go. That one, that symbol up there is infinity, by the way. I want to do these three guys, and that's pretty much type 1 covered. I know there's lots more examples, but we can't do hours of these. We just don't have the time. So I'm going to jump right into a version of question 16, which is integral from 2 to infinity. And I would probably rewrite it, and while I'm at it, factor. And we got that guy. So let's put that away so it's not going to distract us. Oops, that's my next stuff coming. Okay. We need to have strategies, right? We know how we're going to set it up. That's going to be the limit as t tends to infinity, and the integral from 2 to t. But what's this guy going to be? How are we going to rewrite this guy in a way that's going to allow us to integrate it? Do you recognize it? Agreed. And then use a cover-up method. So I'm going to have a v plus 8. I'm going to have a v minus 1. I guess I'm going to have a dv. Let's see what we get. If I cover that up, you're going to get negative a ninth. If you do the other one, you're going to get plus a ninth. You can check it later, but pretty sure that's right. That means now that we can find this integral by this guy is 1/9, the natural log of v plus 8, and this guy is 1/9, the natural log of v minus 1, and it's going to be evaluated at v equals 2 to v equals t. We're comfortable about the antiderivative of this is a log, and this one here is also a log. And then what we're going to do is plug in t. So that's 1/9, the log of t plus 8, plus 1/9, the log of t take away 1, subtract negative 1/9, the log of 10, and add 1/9, the log of 1, which is 0, so I won't bother writing. So we are now at this stage. We have this fella. This one. And I don't know why that says that's a t. And that guy. Now, what you might think you're going to do is brute force it right now, but if you try that, you're going to have a lot of problems, because you're going to have a negative infinity and a plus infinity, in which case you really don't know what's going on. So what I'm going to do instead is I'm going to do style points. First thing is I'm going to pull out 1/9 as a common factor, and I'm going to rearrange the order a little bit, putting this guy first, that guy second, and subtract this guy last. Now, since we have logs here, I should be able to combine them into a single log. So this log plus this log, take away that log. Well, when you add logs, you multiply the things together. And when you subtract a log, you divide it. So far, so good? Are we comfortable with where we are right now? Okay, let's just take it a little bit further. One ninth, the natural log of 10t take away 1 over t add 8. Okay, now we're ready to get the answer. Don't worry about the 1/9 in the log. Let's just focus right now on this fraction. As t goes to infinity, what will 10t take away 1 divided by t plus 8? What will that become? Now you can either do it with L'Hopital or you can divide top and bottom by t. But what will this become? If I say to you, what's the limit as t tends to infinity of that fraction, what do you get?
Would it be 10?
Yeah. Couldn't you just L'Hopital and get 10 on the top, 1 on the bottom? Couldn't you divide them by t, do it that way? Anyway, you're going to get 10. So it's 1/9 the natural log of 10. So this one converges. And that's what it converges to. So that was an example of us using partial fractions. Here's question 17. I'll set it up and then we'll worry about how this is going to be solved. It doesn't matter that that's infinity. It doesn't matter that that's 0 t. All that matters right now is how do you integrate z e to the 4z with respect to z? What method do you use to integrate z e to the 4z?
U sub?
Could be. In many cases it is. But if it's not a u sub, then what will it be?
Integration by parts?
Yeah. Now, if that was 4z squared, wouldn't it be a u sub? But because it's 4z, you see it doesn't really play well, right? So if you're going to do integration by parts, don't we have to decide who is f of z and who is going to be g of z? I think in this case, it's pretty straightforward, right? It's not one of the weird ones. The f of z would be z, and so its derivative would be 1. And g of z would be that fella, and the integral of that fella is definitely e to the 4z. What's missing? What should go at the front here, where my finger is?
1/4.
And now we are ready for integration by parts. When I do u subs, basically I ignore these terms. I don't write them down. If you have to do an integration by parts, I suggest that you don't write them down. Write these limits of integration. Wait until the end when we know everything in z, and then we can do it. So it's f of z, capital G of z, take away f dash z, capital G of z, dz. So it's going to be the limit as t tends to negative infinity of z, 1/4 e to the 4z, take away f dashed, which is 1/4 e to the 4z dz. And then I will tidy it up a little bit. And we're looking at that line. Okay, that's done. Integrating that's not really a big deal. So leave this guy alone, he's already been integrated. Right, if you integrate 1/4 e to the 4z, you get 1/4 e to the 4z times another 1/4. And that's why I now have a 1/16. And at this point, I'll then bring in these guys. So it's z equals t to z equals 0. Let's see what we get. Plug this guy in here and you get basically 0. Plug it in here, you get e to the 0, which is 1. So you get negative 1/16. Take away 4z e to the 4z, take away 1/16 e to the 4z, and what am I doing? Yeah, z's it's not what I should be doing, it should be t's. There we go. So it's 4z, let's rewrite that. This line here should have been the negative 1/16 is good, right? Now, plugging in z's for t's. Take away 1/4 t e to the 4t. Take away 1/16 e to the 4t. Finally got it. And then tidy it up a little bit. Negative 1/16, negative 1/4 t e to the 4t, and plus 1/16 e to the 4t. Okay, we kill that line. Are we now happy with where we are? We comfortable? Right. Now things are going to take a rather nasty little side turn. We are going to try and find out what the limits of each three pieces are when t becomes negative infinity. Well, that guy is pretty easy. Let's do this guy. If you do it with brute force, you get 1/16 e to the 4 times negative infinity, you get that guy. That guy is the same as that guy, which is the same as that guy, which is 0. Are you happy about this term being 0 then? This middle one is not even vaguely pretty. Let's show you what the problem is. I'm trying to find out what this expression is equal to when t goes negative infinity. Well, I might try brute force. If you do negative infinity times negative 1/4, you basically get a positive 1/4 infinity e to the negative infinity. And that's 1/4, and that's infinity, and that's 0. Can you see that there's a big problem? Infinity times 0 is not 0. It might be, but there's no guarantee it's 0. There's no guarantee it's infinity. There's no guarantee that it's not a number somewhere between those two extremes. Brute force fails. So now we're left with, well, how do you get the answer when you can't do brute force? And what you do is you rewrite it like that. Why am I writing this fella like that? What's the reasoning behind it?
L'Hopital.
Right, can't do L'Hopital, now I can. And according to L'Hopital then, it should be the limit as t tends to negative infinity of negative 1/4, that's the derivative of the top guy. And if you do the derivative of the bottom guy, you get that. And that becomes the limit as t tends to negative infinity of positive 1/16 e to the negative 4t. Now, if you plug negative infinity in here, you get 16e. Negative 4 times negative infinity is plus infinity. 1/all of that is infinity. 1/infinity gets you 0. So after all that hard work, we just found out the middle term was 0, and therefore the answer converges to negative 1/16. You see how that question had a lot of different roads that you had to travel, little side issues like how on earth do you get this guy? Right. A lot of different steps. Big question. So we've got one more guy.
Can I ask a quick question about the last one?
Sure.
Why would infinity times 0 not equal 0? just because if you multiply like any number by 0, it'll still be 0.
Well, but isn't it true if you multiply any number by infinity, you get infinity?
Yeah, I guess that makes sense. Okay, gotcha. We're focusing more on the infinity and less on the 0.
Right, and if you want to make your head hurt even more, have we all come to the conclusion that there's different versions of infinity? In other words, some infinities are bigger than other infinities, right? I know we're comfortable with that concept, right? Do you know that there are different versions of zeros? Some zeros are more zero-y than others. So when 0 and infinity fight with each other, you don't know what the answer is. You know, like an infinity on the top and an infinity on the bottom. We don't know the answer to that, right? It's called indeterminate form. Anytime you get a calculation that has no obvious answer, it's typically going to be an indeterminate form. Off the top of my head, here's some indeterminate forms. Right, that one. That one. That one is indeterminate. Would you agree infinity take away infinity? You don't really know what it is because one of those infinities could be totally different size than the other, right? Would you agree 0 over 0 is a bad idea? Indeterminate form. So whenever you get weird combinations, you're probably going to go and do L'Hopital in some way, right? You're going to try and make L'Hopital work for you. In that question there, didn't we have to do some, you know, rewrite it as a fraction essentially? And so if you hit an indeterminate form, L'Hopital's probably going to be the guy that gets you out of trouble. Now, the last one is 19. The integral from negative infinity to 0 of z over z to the 4 plus 9. Let's throw you in the deep end here. What method will I use to solve that guy? Any ideas? What method for z over z to the 4 plus 9? Doesn't matter if you get it wrong. I honestly don't mind students trying and not getting the right answer. I think it's part of that learning process. It's good for you to make mistakes. You learn by them.
Would it be a U sub with the z squared?
Oh, you nailed it. Do you want to share why z squared and not z to the 4 or even z to the 4 plus 9, which is another alternative? Why z squared?
Because you could make the bottom u squared and then cancel out the top with a z squared.
Oh, interesting. Let's see. So we'll differentiate this guy and get 2z. And we'll do the crossover. And then divide both sides by 2z to isolate the dz. Right? Pretty standard. Whenever I do u subs or integration by parts, I tend to ignore the limits of integration until I get back to the z's. So in this case, it's just going to be an integral sign. It's a z. The dz becomes 1 over 2z du. And won't this guy become u squared plus 9? And I don't know why that turned into square roots of 4, right? Wouldn't z to the 4 become u squared plus 9? So far, so good? Right. Z squared is u squared. So this is going to be the limit as t tends to negative infinity of 1/2 1 over u squared plus 9. Let the z's cancel. I like to keep the fractions separate. Okay, this is a memory question. We did do one of these guys before. Can you remember what the integral of 1 over u squared plus 9 is? Okay, someone says something, but I didn't catch it. It's an inverse tan. 1/3. Inverse tan u over 3. You remember we did the 1 over x squared plus a squared guy. That's who this is. So we are now going to have 1/6. Oh, evaluated at z equals t to z equals 0. So at this point, we'll bring in the limits of integration. So when you do z 0, you get 1/6, because that's what they are, the inverse tan of 0 over 3, which is 0. Take away 1/6, the inverse tan of t over 3. Right, would you agree the inverse tan of 0 is 0? So we can forget about that. If you put negative infinity, brute force into this, you are looking at negative 1/6, the inverse tan of negative infinity over 3.
Would we have to put or substitute back in the u?
Oh,
These
damn it, space. You're right, you're right. Too busy not paying attention, that's what I was doing. I was thinking of the next line, and I did say return back to the z squares, and then I decided not to pay any attention to myself. So it's 1/6, the inverse tan of z squared over 3. Right, now I can do it. So it's going to be the limit as t tends to negative infinity, 1/6. Well, can I still call it the inverse tan of 0? Because it still ends up being 0 squared over 3. So that's not really changing anything. But this will be a little bit different. It's the inverse tan of t squared over 3. Now, when we do the brute force, this guy is 0. And this guy is 1/6, the inverse tan. Right, here goes. Negative infinity squared is positive infinity. Positive infinity divided by 3 is still positive infinity. This is not infinite. What is the inverse tan of infinity is in fact a number. It's, you know, the angle that gives you a tangent of infinity. What angle gives you a tangent of infinity? We've seen this guy before. I know it happened yesterday, I think.
Pi over 2.
Pi over 2. So what you've got is negative 1/6 pi over 2, which is negative 1/12 of a pi, and that converges. Are we good with that one? Little hiccup there, but actually, strangely enough, my answer wouldn't have looked that different from the real answer, but that's just coincidence, right? I should change it, and I did. So now we're going to look at the other kind, called improper integrals of type 2. So we're going to try and find the value of these integrals, and the answer is going to be a number, or it's going to be basically infinity, right? It diverges. Now, can you imagine that we tried to sketch 10 over x squared? It would look something like this. And we want to get the integral from 0 to, let's say, 5. And what we have is essentially a vertical asymptote at 0, agreed? For that guy. And you can't just say, well, since this is infinitely, tall, the answer is guaranteed to be infinity. And so every single one of these diverges. Haven't we already found out that the ones that we've just done, the tight ones, don't some of them converge to a number and others are infinite, right? So that's not going to work. What we have to do is essentially figure out how to tackle these questions. So here's our first one. 0 to 5, 10 over x squared. And I'm going to use a trick that we've already done. I'm going to use the limit, but this time it's going to be t tends to 0. And the integral is now going to be from t to 5. And 10x squared, I'm just going to call it 10x to negative 2, so it's easier to integrate. Why did I choose t tends to 0 in this puzzle? What's so special about 0?
Because it's an asymptote, so you can't ever find the actual value of the function at 0.
Right. So do you see what we're doing is avoiding it and using the limit technique, right? And so if you have a vertical asymptote at 7, this will be t tends to 7, right? If you have a vertical asymptote at 70, this will be t equals 70. So notice that you just replace the value on the integral that's causing you the problem. Would you agree 0 is causing the problem? So you replace it by t, right? You find a workaround. How can I get the integral and avoiding plugging in 0, essentially, in this case? Technically speaking, although it makes no difference to anything, the answer is the same. Shouldn't it be called 0 plus? And that's to do with the fact it's a right-handed limit. I know it's a long time ago when we did left and right, but you know, it keep the math lawyers happy, call it 0 plus. And let's see what we have then. So it's going to be the limit as t tends to 0. And this guy is basically a nice power rule. So add 1 to the power and divide by the new power. Evaluate it at x equals t and x equals 5. I'm now going to do a little style point on it. Why do you think it's a good idea to turn this ugly guy into this fraction? Why do you think it's a good idea to do that?
Clarifies.
Yeah, it's going to make it
Yeah,
easier.
that's it.
Yeah, it's going to make it easier, I would say. Let's see if I'm right. So negative 10 fifths. Take away negative 10 over t. So it's now going to be the limit as t tends to 0 plus of negative 2 plus 10 over t. So far, so good. Now, if you can brute force these, so it's negative 2 plus 10 over 0, technically 0 plus. What does 10 over 0 get you? If you take 10 and divide it by 0. No, you don't get 0. That's 0 divided by 10, right? If you took 10 and divided it by 0.00000, right, wouldn't the answer be 20 trillion, zillion? Wouldn't it be infinite? So what you have got here is negative 2 plus infinity. So the answer is infinite and it diverges. So that area would actually be infinitely large. Now, if I had left the guy like this, we would have been looking at a calculation that looks something like this. Would you agree 0 to the power of negative 1 is kind of hard to get your head around? Would you agree 10 times 0 to the power of negative 1, just what on earth is that? Isn't it a little bit easier to see 10 over 0 and get an idea of what it looks like? So that's why you should try and always return back to fractions. So there's another reason why style points are helpful, right? Now, the next one we're going to do is this one I'm calling question 2, although it's very similar to quite a few homework questions, is this one. What value of x does this function have a problem with?
X equals 4.
And because of that, I'm now going to do the limit as t tends to 4, technically 4 minus, the integral from 1 to t. And this thing here is going to have to be rewritten as a rather ugly negative half power. Are we okay with that? You know, 1 over a square root has to be called a negative half power. Now, we'll integrate it using the power rule. Add 1 to the power. And then divide by the new power. And evaluate it to x equals 1 to x equals t. And then I'm going to do my style points. And that's the guy we're going to evaluate at 1 and at t. So it's now going to be the limit as t tends to that. 2 lots of the square root of t take away 4 minus, oh, shooting spice. Is there any way around this? Do you know what my problem is? It's just the way I wrote my question down.
You get a negative in the square root.
Yeah. Can we pretend that I picked a better interval so it wasn't a negative so we can continue this question? This question is impossible to do because of the curve. I didn't realize it. I don't know. I wrote it down here, but I think in my brain I was probably thinking +4, which would have worked. But can we just pretend that's a number, right? Just to get it over with. What's going to happen when you plug in 4 here? Aren't you going to get 2 lots of the square root of 0 minus a number? 0 minus a number, wouldn't it converge? Now, if you want to know what the real version of that question would look like so that you could actually get an answer, how about 4 to 6? If you did that version, you would get a number that you could use, right? But I'm not going to redo that question from scratch. I hope there's enough there to show you that it does converge. Now, before we look at the final one of these for today, let's hide this guy out of the way. Almost every question that involves an improper integral of type 2 is going to have one of these 2 shapes. It's going to be a number over an x cubed, an x squared, right? Some kind of power of x. Or it's going to be 1 over a square root or a cube root or whatever, a 4th root. I can tell you right now which ones are going to converge and which ones will diverge. As long as this power on the bottom is bigger than 1, right? So 10 over x and then upwards. It's always going to diverge. And it can be x minus 1 in brackets squared. It's still going to diverge. And if this is a radical in the bottom, right? A square root, a cube root, a 4th root of anything you like, not just x's, but 1 minus x squared, anything you like, these guys are going to converge. So I can tell you that right off the bat. Powers of x diverges, radicals converge. And it's basically to do with, you know, a minus a half turns into a positive power, it converges. But won't all these guys turn into things with 10 over 0 or whatever and always diverge? So let's look at the last one. And I'm doing a double check that I haven't screwed this question up, and I can tell you it is good. This is a type 2. It has a vertical asymptote. But where is the vertical asymptote? What value of x?
Would it be 1?
it would be at 1. Do you notice that 1 isn't at either end as it was in the previous two questions? Isn't 1 in the middle? Agreed? Which means that we will have to tackle this question by splitting it into two pieces. In other words, we're going to treat it like these questions, right? You see the split at 1. Now you might say, well, why bother doing that? Why do we need to? So before I come back to that, let me try and show you what that might look like. There is a vertical asymptote at x equals 1. And I believe it's positive on this side and it's negative on this side. We are going to be doing it from -2 to 2. So you can imagine we're getting this bit and we're going to get that bit. Would you agree there is at least a possibility that the answer may be infinity? Secondly, if you integrate this guy and ignore the fact that there's a vertical asymptote in it, this answer will always be a number, because the numbers you're going to plug in don't have any infinities attached to them. So I wouldn't even need to do this. I could just do the integral from x equals -2 to 2. And will you trust me, you get an answer -1/2 or something, right? Do you see that that technique doesn't help? You have to figure out what's going on. Now, another problem. Can you imagine we did this answer here, and the answer ends up being -infinity, and we do this answer and it ends up being +infinity. In other words, both pieces diverge. Can you imagine +infinity, -infinity, right? That could happen. What do we do for the answer to this integral if that happens? And don't say 0, because couldn't one of those infinities be bigger than the other? We will say it diverges. Now, when you are doing each of these two questions, you need to only do one at a time. So let's suppose we do this one. If this one is any version of infinity, I don't care if it's plus or minus infinity. When that happens, stop. The complete answer is diverges. Does it matter if the other one kind of cancels out? Nope, it still counts as diverging. So, okay, that means we're going to have to do one or other of these. I can't remember which of these two it is. Which one do you want me to do? The left-hand piece or the right-hand piece? Excuse me.
Tornado warning, everyone.
I had just got a tornado warning.
Yeah, so
Yeah,
Yeah,
I
same
saw this
here.
morning
That was crazy.
online that we are
Okay.
at a mild risk of a tornado.
Well, it better not come near my house because I owe so much money on it that it's not good.
Well, this is the map, and the dark green portion is where we're at risk. So we are not part of that dark green area.
So we're good.
We're good.
Okay. Which piece do you want? The left or the right? Which one do you want me to do?
Do the left one first.
Okay, so we're going to do this fella here, right? So it's going to be the limit as t tends to 1 of -2 to t 1 over x minus 1 cubed. Now I happen to know this is going to diverge, but that's fine. It's going to be the limit as t tends to 1 of -2 to t x minus 1 to -3 dx. Technically speaking, that's 1 minus. It's going to be the limit as t tends to 1. Add 1 to the power, divide by the new power. and evaluate from -2 to t. Do some style points on it. And call it that guy. Put in the limits of integration next. And you get -1 over 2 lots of t take away 1 squared. Take away -1 over -3 squared is +9, so 18ths. So we are looking at -1 over 2 lots of t minus 1 squared plus 1/18. Okay, let's plug in 1 and see what we get. We get -1 over 0 plus 1/18. What does 1 over 0 tell us? What's 1 over 0 equal to?
Would that be infinity?
Yeah. And do I really care if it's plus or minus? Not really. Would you agree that this diverges? If you really want to know, it's minus infinity because it's below the x-axis, but whatever. Since that one is broke, right? Since this one's infinity, I don't need to bother about the other one, do I? So the final answer is that integral diverges. Are we good with those? Right, let's have a look at the homework questions for the time we've got left. We'll talk through some of them, and that will be us hopefully finished. So let's start at the top. Question 1A, type 1 or type 2? Type 1.
2.
Correct. Has it got a vertical asymptote in it? Yes. What's the bad value of x? 8. If you put that whole package together, you're looking at a type 8, aren't you? A type 2, I should say, at 8. So it'd be that answer. What's question B? Type 1 or type 2?
Type 1.
Okay. Would you agree type 1? It's got an infinite in it. Right, type 1, type 2, type 1, type 2, you figure that out. These are all type 1s, so we won't worry too much about them right now. You know, anything with an infinity is a type 1. Right, these are still type 1. Okay, we've hit that one, but didn't we do one like that in class? So I won't need to worry about that one. Done something like that, but this time it works. Done something like that. Okay. Question 22. Where is the problem? It's a type 2 integral. I can tell it's a type 2. If these are numbers, won't it be a type 2? Because a type 1, one of them, at least one of them is infinity, right? And a type 1, one of those is an infinity. So if you don't see infinities, it's going to be a type 2. Where is the problem in this question? What's the value of x?
Zero.
0. So isn't that one that you'll have to split into 2 pieces? And so -2 is 0 and 0 is 3. Would you agree this one has a problem at 1, but we've done one similar to it? Well, if you integrate 7 over the square root of 1 minus x squared, don't make your life hard. Don't go u subs, don't go integration by parts. Think simpler. What is the integral of 7 over the square root of 1 minus x squared? It belongs to the I have got a good memory category.
7 times 10%.
Okay, did you see inverse sine, Sabrina? Yeah. So 7 inverse sines. Is that one going to converge just looking at it? Can you tell? Doesn't it have a square root in the bottom? It's going to converge. Wouldn't that be actually the same question, it looks like, at least in mine? And that's the last question. Would you agree that that guy has a problem at 1? And so you'll have to split it into 2, 0 to 1 and 1 to 9. Will that one converge? Just looking at it, will it converge? Square root in the bottom, will it converge?
Yes.
Yes. If it was 6 over x minus 1 in brackets cubed, right? So instead of a cube root, a cube, wouldn't it diverge? Remember the little shortcut? If it's powers on the bottom, like x cubes, x squares, it diverges. If it's radicals, square roots, and cube roots in the bottom, it will converge. So if you already know what it's going to do, won't that make it a little bit easier to check you're working? Because if you don't get it converged, but you know it should, you've probably done something wrong.